believe this man and how he says that he can teach you how to be a sugar ninja. Only enzymes within the cell can do this job. Please watch for educational purposes.
My name is Thomas Varkey, and I am the Sugar Ninja.
Hi-ya!
My job is to help the cell start off cellular respiration. Cellular respiration is the process of breaking down glucose to create adenosine triphosphate. The first step of cellular respiration is glycolysis, or sugar cutting, which leads to the formation of acetyl-CoA. First, I take a glucose molecule and phosphorylate it using one ATP molecule. Adenosine triphosphate, or ATP, is the molecule used to store energy in the cell. This turns the glucose into glucose 6-phosphate, with the phosphate bonded onto the 6th carbon. I did this to add energy to break the bonds between the carbons. However, I still need more energy to break the bonds to make two separate carbon chains. To provide this energy, I add another phosphate to the glucose 6-phosphate, turning it into fructose 1,6-biphosphate, a molecule that has enough energy to be cut in half. I then chop the fructose 1,6-biphosphate in half. The two pieces are called glycyrrhizide 3-phosphate, which has a phosphate group on the 3rd carbon. Then I take two NAD molecules, these are electron carriers, and smash them onto the glycyrrhizide 3-phosphate molecules. They take two hydrogen ions and two electrons, one from each glycyrrhizide 3-phosphate. These additions change to the name of the NAD to NADH, and the two NADH molecules go to the electron transport chain inside of the mitochondria. They carry the H+ ions and the electrons so that they can be used to make even more ATPs inside of the mitochondria. After that, the two glycyrrhizide 3-phosphate molecules create two ATPs through substrate-level phosphorylation. When the substrate makes adenosine triphosphate by adding a phosphate molecule to the adenosine diphosphate, and become two 3-phosphoglycerate molecules, which release H2O or water to become two phosphophenylpyruvate carbon chains. After another round of substrate-level phosphorylation, which creates two more ATPs, the phosphophenylpyruvate then becomes pyruvate, the final product of glycolysis. This ninja cutting action all takes place in the cytosol of the cell. My ninja friend, the mitochondria, then takes two coenzyme A's, an important coenzyme which helps the mitochondria to break down the pyruvate molecules even more so during the Krebs cycle, and two NADHs to change the pyruvate molecule into acetyl-CoA molecules, which can then be used in the Krebs cycle to make even more ATPs. This transition step releases two NADHs and two carbon dioxide. The overall cutting action from glycolysis gave us two net ATPs. 4 were created, but 2 were used, so we only get 2 net and 4 NADHs.
Hey, sugar. Come on over here, sweetie. Let's break it down. Glycolysis is a series of reactions, enzymatic actions, energy transactions. Takes glucose, a molecules of sugary, breaks it down for NADH and ATP. It's an anaerobic cytoplasmic pathway that amazes. Organized easily into 3 phases: investment, cleavage, and energy harvest. Tell me later which one you like best. Investment, activation, energy supplied. Cleavage, our 6-carbon sugar divides. Harvest, we get our energy yield. So beautiful, so intricate, keep your eyes peeled. Glycolysis, come on sugar for the breakdown.